Hey guys, it's Mr. Washahi, and this lesson is going to be working on solving two-step equations. However, this is going to be whenever you have a fraction in the mix. So what I mean by that is, let's say we got x over 4 plus 4 equals 11. A lot of times when we do fractions, you'll see that your x, y, or z, whatever your variable is, kind of next to your coefficient. That means they're being multiplied. So in this case, x isn't being multiplied by 4. X is actually being divided by 4 because it's in a fraction. So we're still going to follow our same steps in using opposite operations or inverse operations, except this tells us we're going to be, instead of dividing by 4, we're going to be multiplying by 4. Okay? So let's just go through the steps. So since we're thinking opposite operations, we're going to zero out this 4 by subtracting 4 from each side. Whatever you do to one side, you do to the other. So now I got x divided by 4 equals 7. So again, we're going opposite operations. The opposite of dividing by 4 is actually multiplying by 4. So that's what you're going to do to get rid of this 4, to turn it into a 1, because you still want to have 1x. And now you do the same thing to the other side. 7 times 4, well, that gets you 28. Okay, you can even check your answer. 28 divided by 4, because that's what we think x is. Well, 28 divided by 4 is 7. 7 plus 4 does equal 11, so this checks out. So that's pretty straightforward whenever you just have an x as a numerator. However, it does get a little trickier whenever you see something like this. Let's say we got 5 over 7x, okay, minus 2 equals 13. So now we have a full-on fraction. This is 5/7 of an x. That means you don't have a full x, you got 5/7 of it. So you're still going to go the same thing, but I'm going to show you guys here in a moment how it might be a little different. Let's go ahead and zero out this minus 2. So you zero a negative by adding. Do the same thing to each side. That'll get us 15 on this side, 0 there. 5/7 of an x equals 15. Okay, so let's go kind of review as to multiplying fractions. Let's say I had 5/7 times 7. Let's say I wanted to multiply those two numbers, those two real numbers. I first want to turn my 7 into a fraction by giving it a 1, a denominator 1. Think of what we're doing. We're going to multiply our numerators. 5 times 7. You do the same thing with your denominators. But then to simplify it, we're going to divide by the denominator. 35 divided by 7. That'll get you 5. So think about it. We multiplied by the denominator, and then we divided by the, multiplied by the numerator and divided by the denominator. So since we're thinking fractions, thinking opposite operations, that means we're going to do the opposite of that. We're going to divide by the numerator and then multiply by the denominator to get rid of this fraction. Think about the relationship between 5/7 and 7/5. What would you call that when you see a fraction that's been, I guess you would say, flipped over? You're right, we are multiplying by the reciprocal. So always, whenever you see a fraction attached to your variable, to get rid of it, you multiply by the reciprocal. Because we'll just multiply across and they'll reduce and turn into 1. So 7/5 times 5/7 turns into just 1x. But you've got to do the same thing to the other side. Okay? 7 times 15, that gets us 105. Well, 5 times 1, that just gets us 5. And if we kind of divide off to the side, just to reduce, 5 goes into 10 twice, 5 goes into 1 once, so x equals 21. So always remember, if you're solving an equation and you're trying to get rid of a fraction, multiply by the reciprocal. Multiply by the reciprocal, okay? If I got 2/3 x, or let's use it, 2/3 y equals 20. Okay, well, I want to get just y, so I'm going to multiply by the reciprocal. The reciprocal 2/3 is 3/2. So you do the same thing to the other side. Okay, y equals 60 over 2. 60 divided by 2 is 30. Okay, so just multiply by the reciprocal. Alright, so you have some practice problems. Go ahead and give those a shot. Feel free to rewatch this video if you need to. Alright, good luck.